Hi, this is Marnie LaNoue presenting the first in our series of mini research rounds for Carillion Clinic. My apologies to the audience who were actually in attendance this morning. We didn't get that captured. We will remedy that next time. So part one of the series is what we're doing today. It's about study design and causality. Again, I'm Marnie LaNoue. I'm the principal scientist at Evidentia Science. This was presented for Carillion Clinic, Department of Medicine. The study we're going to be talking about is the one shown here, comparing treatment effectiveness and patient-reported outcome measures of 4 treatment options for obstructive sleep apnea. This was published in the Journal of Oral and Maxillofacial Surgery in 2024. I present this because it's an interesting study design and an interesting project, and also because the lead author on it was my PhD student. This was his PhD project. So this is Robert Diecidue, who's the chair of oral and maxillofacial surgery at Thomas Jefferson University. This first topic that we're tackling in the mini rounds is about study design and causality. It's not the most trivial of the questions that can be asked about any study, but I thought we would start here as it did, in fact, spur some interesting audience participation. We're going to ask the question, what kind of study design is presented in the study, and to what extent does the study design support a causal inference about treatment differences? And to answer that question, we're going to take a look at the abstract and a little bit of the methods of the paper. So the abstract indicates that this was a study, a retrospective study, described as a retrospective cohort study. And it compared 4 common treatment options for obstructive sleep apnea, in particular, the CPAP machine, a mandibular advancement device, surgery, so mandibular surgery, and an upper airway stimulator, a device that can be implanted in a patient that stimulates them each time they have an apneic episode. The study is retrospective in that existing health record data was used. Patients had already received the treatments in question, and they were not randomly assigned to those treatment groups. The primary outcome in this study was an objective measure of mean disease alleviation. So it's a calculated variable that estimates the effectiveness of each of the treatments in terms of the improvement in apnea. I highlight here the pre-existing nature of these treatment groups. So patients who get a CPAP machine for a particular reason. Patients who get a surgical intervention get a surgical intervention for a specific reason. And in a non-randomized study, those pre-existing differences between the groups can become very important. And in fact, in this particular case, if you are familiar with the delivery of healthcare and the way insurers work, you might know that the first line of treatment that will be paid for by insurance for a patient with apnea is the CPAP machine. And then if a patient fails at a CPAP, they are advanced to the next line of treatment, the next most expensive one. And that sort of continues across the 4 treatment modalities that are investigated in this study, from CPAP to the mandibular advancement device, which is just a device that goes in the mouth. Those are the non-surgical options. Then they might move to the first surgical intervention, which is the placement of the stimulator, and then the actual mandibular surgery, which is, jaw maxillomandibular surgery, is the final sort of modality that might be used to treat a patient who had not responded to any of the other treatments. That's important to note. Not only are these patients non-randomized, but there are profound differences between the groups, and the groups are somewhat staged. The patients in each group probably at some other point existed in another group. We're going to talk about what that means. But before we do that, we're going to kind of try to just come up with a statement for the study design here. There's another unusual feature of this study, which is it is a pre-existing retrospective chart review study using an objective outcome that's calculated from measurements that were commonly taken for apneic patients. But the the investigator, wanted also to know about quality of life. So he prospectively reached out to some of the patients in each group and administered a patient-reported outcome measure. So after the treatment had already occurred in the past and the data were available in the medical record, and that could have been a latency, of a very short time or a very long time, that you'll see in the paper when we sort of work through it. But then at the time that the study was initiated, the investigator then attempted prospectively to reach out to patients and administer a patient-reported outcome measure. So this study has both a retrospective and a prospective component. It is a between-group comparison that uses the word efficacy or effectiveness. The implication is that the goal of the study is to find support a causal inference with respect to these treatments and their effect on the apnea outcome. A causal inference with respect to both the effectiveness of the treatments on the apneic outcome and also on the patient-reported outcome measure, which was measured prospectively. So based on those elements of the study, what could we arrive at as a statement of the study design here? There is no right answer. And in fact, I have come to the conclusion, and I try to tell my students now, there are as many study designs as there are research questions. And this study is a particularly good example of that. It was a clever way of leveraging pre-existing health record data, and then also prospectively conducting, kind of a study within a study. So it has both retrospective and prospective elements. It is what we would characterize as a quasi-experimental study. And we talked a little bit in our live session about what differentiates or what makes a quasi-experimental study quasi-experimental. We generally know and can recognize an experiment when we see one, right? That's a randomized controlled trial. Randomization is the key feature of experimentation, that there's a manipulation made. The manipulation is the assignment to treatment group in our context. So quasi-experiments are all those studies which did not have randomization, but which still have features of a study that is attempting to draw a causal inference. Sometimes it's difficult to kind of tease this out, but generally in the healthcare setting, even when we don't randomize, and in the example we're talking about here, this is a study about treatments for sleep apnea. We want to know if the treatments have a differential causal impact on the outcome. Of course we want to know that. It doesn't make sense that we would be interested in anything else. That is what makes this study a quasi-experiment, that we are actually asking. We would ask an experimental question if we could, and in this case we did not. There are things that are called manipulable causes. They could have been manipulated. That is the case here. Theoretically, patients could have been randomly assigned to one of these 4 treatment groups. And then there are things that are non-manipulable. So there are things that we're interested in knowing the causal effects of, but which we cannot ethically or effectively or reasonably randomize to. So things like substance use or childhood maltreatment, some effects that we're interested in for which randomization is not possible. And then there are effects that we're interested in for which randomization was not done for whatever reason. And this is one of the latter of those instances. This study design has both a quantitative and a qualitative component. It is a quasi-experiment that uses both retrospective and prospective data. It has longitudinal and cross-sectional features. Longitudinal in that there was a time when these patients were treated, not all at the same time. There was a time at which their outcomes were assessed, which was all at the same time, a cross-section of when the study started. The the investigator went back in the health record, pulled the available data to calculate the objective outcome measure, and then at a later time point, they were sampled again for the patient-reported outcome measure. And the study has both a subjective, meaning a patient-reported, and an objective outcome. So this particular study has basically all of the elements of every study design that there is. And again, I say that only to make the point that there are as many study designs as there are research questions. This slide in particular, though, I think is a good one. I think it does capture kind of the fundamental or key dimensions that are necessary to fully describe a study. And so when thinking about study descriptors, I would encourage you to try to use as many of these dimensions as possible. Probably all of them. It's difficult to think of a study in our sort of health outcomes setting where we wouldn't be interested in knowing all of these particular pieces of a study that we were talking about. In this particular study, it's also interesting to ask where it lies on the efficacy effectiveness continuum, which is basically what is shown in this slide. This slide is from one of the National Institutes of Health institutes. I think it might be NAID. But it's a nice slide that depicts, or a nice graphic that depicts the continuum of studies along the continuum of evidence generation, and where we generally fall in our business as healthcare deliverers or healthcare scientists is at the sort of intervention refinement stage, right? We have an intervention, we're interested in knowing if it works. We have a mechanistic or plausible biological model for why it should work. We develop it, we optimize it, and then we do an efficacy test, where efficacy technically means the effect, the test of the effect. So efficacy trials are usually randomized controlled trials when possible. Efficacy is synonymous with an RCT when possible. An RCT is the gold standard for efficacy evidence. And an RCT is a demonstration of efficacy evidence under tightly controlled conditions, tightly controlled experimental conditions, randomization, strict controls over the conduct of the trial, strict follow-up protocols, strict outcome measurement protocols, etc. So that tells us efficacy technically means, does this thing work under optimal conditions? And then we move a little further to the right to effectiveness. So effectiveness means, does it work in the real world? Does it still work? And that is a key dividing line right there, because it's quite easy for things to be efficacious in clinical settings and clinical trials, but not be at all effective when they are implemented in the real world. A key example of that is a study that came out regarding the outcomes of a number of studies that had been used to create the treatment guidelines for asthma. So this is quite an old paper, but an important one. It's Travers et al. From 2007, and it's called External Validity of RCTs in Asthma. To whom do the results of the trials apply? And they looked at all of the patients who had been treated with the predominant treatment modality in a community sample, and then asked the question of whether or not those patients would have qualified for any of the 17 of the RCTs that had been used to support the guidelines in that treatment. It was only 4%. So the distinction between efficacy and effectiveness is an incredibly important one. And it was only really recently, in the last 10 or 15 years, that the idea of effectiveness and pragmatic research, and then even further downstream from there. So let's say we have an efficacious treatment, we believe it is also effective, right? And then now we want to know, well, is it being used, right? In what settings is it being used, and are there interactions between the setting and the treatment, and what about the providers? Will they prescribe it? So we've come a long way in our sophistication in terms of thinking about what it means for something to work. And that was sort of the point that I wanted to make about this particular trial, is that it is an effectiveness study, probably because it is a post hoc retrospective leveraging of existing health record data for patients who have already been treated and were not randomized. But to randomize to one of four groups for obstructive sleep apnea patients where one of the groups is a very invasive surgical intervention, it would be a very difficult study to run. I will make one other point that we talked about in our in-person meeting. This is a comparative effectiveness study, which technically means a head-to-head comparison of treatments. There is no placebo or control condition. Comparative effectiveness is a special pocket of research that was funded by the Affordable Care Act for the first time in 2010, and then when the ACA was reauthorized in 2020, the money that was earmarked for comparative effectiveness research is the money that funds the Patient-Centered Outcomes Research Institute, whose sole mandate it is to fund comparative effectiveness research. And much of the rationale for the earmarking of that money and for the development of the comparative effectiveness funder, which is PCORI, was the identification by everyone that we had all of this medical record data laying around that we were wasting. And wouldn't it be nice if we worked on the methods for getting better inferences out of these pre-existing treatment groups? So I think that's just an important piece of context to keep in mind. So we've talked about the study design here, and we've talked a little bit about the context for this study in terms of where it lies on the efficacy effectiveness continuum. So let's spend a little bit of time talking about the potential for a causal inference. And we've been hinting at this, and we did have a robust discussion in person. The problem here is that these groups are not randomized. So non-randomized groups bring with them a lot of other features, group-linked features or characteristics of the people in those groups that don't have anything to do with the treatment that they're being administered. That is the most technical definition for the idea of bias. In particular, well, if you do just a random Google search, you will find 7 different definitions for different kinds of bias. When we're talking specifically about whether or not a study can support a causal inference, what we're talking about is what's shown on this slide, sort of what is the strength or the quality of the evidence to support a causal inference. A randomized control trial is not at the top of this pyramid, but it is at the top of the pyramid for single studies. So above that, you get to aggregations of studies, and we'll talk about that in future series. An RCT is the gold standard for efficacy evidence for a causal inference. The inference is, it is the difference in group membership that caused differences in the outcome. So what we would be wanting to say here is, yes, it's whether you got a CPAP versus the mandibular advancement device versus mandibular surgery that caused differences in your outcomes. We want to say that. We want to be able to say, that it was the group that people were in that drove differences in their outcomes. And we don't have a randomized trial. So the question is one of pre-existing group differences, which is bias. Someone in our discussion this morning called it selection bias, which is what it is. It's the idea that patients were selected into these groups rather than randomly assigned. They selected themselves, their insurance companies selected them, their physicians selected them. They were selected rather than randomly assigned. That's what selection bias means. Oftentimes in our business, you'll hear people just calling that bias. There was bias present. That's why it's important for us to understand just fundamentally what is happening mechanistically rather than getting caught up on what it's called. When groups are non-randomly assigned, then they are expected to differ in other important ways than just the treatment that they received. So that's why this is a non-randomized trial. This is a non-randomized sort of cohort study. And I think that's why the investigator here chose to call this a cohort study, because there was no control at all. This was just pre-selected groups of patients. who had already gotten these treatments. So it's pretty far down on the evidence pyramid that's shown here. So what can you do in those cases? Because you don't want to throw that data away. And as I just said, money and a lot of effort has gone into thinking about how we might strengthen inferences in those cases and not waste all of that very valuable medical record data. And so there are a couple of approaches, and we're going to be talking about them a lot, but they are just two things. You can either try to match people across the groups. So you pick a 35-year-old male who lives in a certain zip code and just make sure that one of him is present in every group. There are very sophisticated approaches to matching, but that's the gist of it. Or you can try to exert control with some statistical techniques. Those are our only options. They're not terrible options, and in fact, a very well done, a very sophisticated matched project can, in my opinion, rival or even exceed the level of evidence that an RCT can. An RCT is going to be limited in the number of people that can be recruited and enrolled. And a distributed electronic health record across a system, a multi-state system, could have tens of thousands of patients available in it. Even the most expensive multi-site RCT is going to be limited by volunteerism, so only patients who volunteer for studies end up in studies, the generalizability problem that we talked about before, the cost and expense of controlling treatments across multiple sites, all of that time and effort. RCTs are very hard to do and very expensive. If we had techniques that we could use to emulate an RCT in existing data, we would want to use them, right? We would have hundreds of thousands of data points available to us. And that's sort of the direction, that the distinction between, an RCT is great. Yes, we should do them when we can, but why not try to also support and strengthen our inferencing in non-experimental studies? And that's sort of what is at the core of comparative effectiveness research. So the thing that we've been talking about, the issue of individuals having pre-selected themselves into these groups, is one of bias or validity. Validity means truth. And so internal validity technically means the truth of the causal inference being drawn. How sound is the causal inference being drawn? If you're a sort of a hardliner like me, you believe that internal validity, that the term internal validity should be reserved only for those studies where there is an attempt to draw a causal inference, because internal validity only applies to instances where there is a causal inference being made. Internal validity means the strength or the soundness of the causal inference being drawn. If there is no causal inference attempted, there can be no internal validity. And that is consistent with the sort of the medical framing of this as risk of bias, where risk of bias generally means, were there any reason to believe that the patients differed in any important way except for group membership? We're going to unpack this much more in the future. In addition, we're going to unpack external validity and applicability, and then we're going to frame that all in the context of study quality. But here, I think we've gotten a nice introduction to study design, and we've started to think about what it would mean to draw causal inferences in non-experimental data. So thank you very much, and I will see you next time.